Assalamu alaikum dear students. We are solving this exercise 10.3. Today we will continue this very top in this exercise. The question number 10 of this exercise is the line through the points h3 and 4 1. So we have 2 points h3 and 4 1, and the line through these 2 points, that is the line passes through these 2 points, intersects another line x minus 7y plus 5 equals to 0 at right angles. We have to find the value of h. Here we will use the condition of perpendicularity in terms of slope. Now the slope of line passing through the point h3 and 4 1 is m1 is given by the difference of y coordinates upon the difference of x coordinates, that is 1 minus 3 upon 4 minus h, that is minus 2 upon 4 minus h. Also the slope of the given line to which line through these 2 points intersects at right angles. Now the given line is x minus 7y plus 5, or we can write this as 7y equals to x plus 5, or we can again write this in the form of y equals to mx plus c, which is 1 upon 7x plus 5 by 7. So this means that slope of this second line, that is m2, is 1 upon 7, because on comparing with y equals to mx plus c, here m is 1 upon 7. So slope of this line is 1 upon 7. Now by given condition, the line through these points h3 and 4 1 intersects this line whose slope is m2 equals to 1 upon 7 at right angles. This means that when two lines are perpendicular, then the product of their slopes is minus 1. Hence m1 into m2 is minus 1. m1 is minus 2 upon 4 minus h. m2 is 1 upon 7. So this equals to minus 1. By multiplication, we simply get h is equal to 26 upon 7. This means that the value of h is 26 upon 7 when the line through h3 and 4 1 intersects the line x minus 7y plus 5 equals to 0 orthogonally or at right angles. Now question number 12. Two lines passing through 2 3. We have a point through which two lines passes, intersects each other at 60 degree. So this means the acute angle between these two lines which passes through 2 and 3 is 60 degree. If slope of one line is 2, among these two lines the slope of one line is 2, find the equation of line second or another line. Here m1 means slope of line first line is 2. Let m2 be the slope of line second. The acute angle between two is given theta equals to 60 degree, which implies that tan of theta equals to modulus of m1 minus m2 upon 1 plus m1 m2, or tan 60 equals to m2 is m1 is 2, m2 is m2. So on substituting, we simply get tan 60 is equal to modulus of 2 minus m2 upon 1 plus twice m2. Now tan 60 is root 3, which implies that this. On squaring, we simply get 3 equals to 2 minus m2 square upon 1 plus twice m2, because 2 minus m2 is this upon 1 plus 2 m2 is either positive or negative, and the square of any positive or negative is again positive. So simply on squaring, we get 3 equals to this very quantity. By cross multiplication, we simply get 11 m2 square plus 16 m2 minus 1 equals to 0. So m2 is variable. This means that we have a quadratic equation. Variable is m2. So using the quadratic rule, m2 equals to simply minus 8 plus minus 5 root 3 upon 11. So either m2 is minus 8 plus 5 root upon 11, or m2 equals to minus 8 minus 5 root 3 upon 11. But this line passes through point 2 3, because these two lines actually whose slope is 2 and this whose slope is this very quantity minus 8 plus 5 root 3 upon 11, or minus 8 minus 5 root upon 3 upon 11 intersects at 60 degree and passing through 2 3. This means that we have a slope, we have a point. So using the slope point form, equation of the second line is y minus 3 equals to m2 into x minus 2. Here m2 is given by first, so this is the required equation of second line. Now find the equation of a right bisector of a line segment joining points 3, 4 and minus 1, 2. Right bisector simply means that line which intersects the given line perpendicularly at midpoint. So bisector means which line which divides the line segment into two equal parts, and right bisector means that line which divides the given line into two equal parts but intersects the given line at 90 degree. Now the line passing through the points 3, 4 and minus 1, 2, its slope is given by m1, which is by difference of x coordinates and difference of y coordinates upon x coordinates, that is simply 1 upon 2. Similarly, coordinates of midpoint of this line is by given by section formula, that is 1 upon 3. Now the slope of the line which is perpendicular to this line segment, whose slope is 1 upon 2 means this line, that is whose, because its slope is 1 upon 2, is given by m2 equals to minus 1 upon m1 equals to simply minus 2. So slope of that line which is perpendicular to this very line is minus 2. Now if this perpendicular passes through point, this midpoint of this, that is 1, 3, then it becomes perpendicular bisector. Hence its equation is given by slope point form, because we have a point through which it passes, that is 1, 3, and its slope is minus 2, which we calculated by using the condition of perpendicularity and finding the slope of the line segment joining 3, 4 and minus 1, 2. Hence we simply get y minus 3 equals to minus 2 into x minus 1, which is the slope point form, that is y minus y naught equals to m times x minus x naught. After simplification we simply get 2x plus y equals to 5. So this is the equation of required right bisector. Now another problem is find the coordinates of the foot of perpendicular from minus 1, 3 to the line 3x minus 4y minus 16 equals to 0. We have a line that is 3x minus 4y minus 16 equals to 0 at a point minus 1, 3. From minus 1, 3 we draw a perpendicular on this line, that is it intersects it at point suppose A. So we have to find what are the coordinates of point A, means the foot of perpendicular. Here slope of, let AB be the coordinates of this foot of perpendicular. Now the slope of this perpendicular is minus b minus 3 upon a plus 1, because its 2 points are given, or it passes through 2 points. Using 2-point formula we simply get b minus 3 upon a plus 1. So this is the slope of perpendicular. Now the slope of line 3x minus 4y minus 16 equals to 0 is given. Firstly, converting it into slope intercept form, which is y equals to 3 by 4x minus 16 upon 4, we get its slope is, we simply get the slope of this line, that is 3x minus 4y minus 16 equals to 0 is 3 by 4. So this line, that is 3x minus 4y minus 16, is perpendicular. By condition of perpendicularity, 3 by 4 into the slope of perpendicular is minus 1. Or we simply get, by simplifying this expression, we get equation, we get 4a plus 3b equals to 5. So name it first. Now the foot of this perpendicular lies on the line, which implies that the coordinates of a and the coordinates of this point satisfies the given line, the given equation. That is, on putting x equals to a, b, y equals to b in equation of line, we simply get 3a minus 4b equals to 16. So we have equation first, second, a and b are the variables. So we have linear equation in two variables. So on solving this, we simply get a equals to 68 upon 25, b equals to 49 upon 25. Hence the coordinates of the foot of perpendicular from minus 1, 3 to the line 3x minus 4y minus 16 equals to 0, or 68 upon 25, 49 upon 25. So these are the required coordinates of foot of perpendicular from minus 1 to 3. So thank you.